Hi, this is section 50 in advanced geometry. Today we're talking about congruence and corresponding parts, and we're going to be talking about congruent figures, most likely triangles, but they can be any figure. Triangles that have the same size and same shape are called congruent triangles. Any figure that's the same size, same shape are congruent figures, most likely talking about triangles. And if they're truly congruent triangles, this is what's got to happen. There's got to be all three pairs of corresponding angles congruent to each other, and all three pairs of corresponding sides are congruent to each other. So here's what they give us right here. They say this guy right here, this is called a congruent statement, that triangle ABC is congruent to triangle RST. And from this statement alone, we can see what angles correspond to each other and what segments correspond to each other, all by reading the statement. Now, there is a picture provided, but what we want to do is just read from the statement. If triangle ABC is congruent to triangle RST, here's all six pairs of parts, and you can list them off to the side of this picture with me. Since A comes first in this congruent statement, it will correspond with what comes first in this triangle's statement right here also, which is R. We know that angle A will be congruent to angle R. And if you look in the picture, you can see that by way of the arc marks. Angle A has one arc mark in it, and angle R has one arc mark in it. Also, since B comes second in this congruent statement, it will correspond with what comes second in that other part. So angle B is congruent to angle S, and that should match up in our picture. B has two arc marks, S has two arc marks. And finally, what comes last will correspond with what comes last. Angle C is congruent to angle T. These are corresponding parts of these congruent figures, so they should be congruent to each other. And you can see the triple arc marks match up with the triple arc marks. But see, those are only the angles. We can also use this congruent statement to figure out the segments. So like, what you do is you just take two letters at a time. If you want to make segment AB, pick on these two. It will correspond with segment RS. So segment AB should be congruent to segment RS. The first two correspond with the first two. We could also use the last two guys, if I switch colors here, segment BC and segment RS. And you can tell in the picture that they match up. Segment BC has three tick marks. Segment RBC3 is timeout. Yeah, that seemed kind of funny for me because I made a mistake. It's not segment BC and segment RS, it's segment BC and segment ST. My bad. So segment BC and segment ST both have three tick marks on them. So, yep, even us perfect people like me, yeah, I'm perfect, make mistakes. So my bad. So the first two went together, the last two went together, and then what you do is you use this statement to do the first guy and the last guy, right? Segment AC should correspond with segment RT. So segment AC is congruent to segment RT. Because these figures are congruent, any pair of corresponding parts is also congruent to each other. So we're doing a little thing called corresponding parts of congruent figures are congruent, CPCF congruence. We'll use that for a justification later this chapter, but if you are given congruent figures, any pair of parts that correspond with each other will also be congruent to each other. So it says show that the polygons are congruent by identifying all congruent corresponding parts, then write a congruent statement. We're going to start with the congruent statement. The congruent statement is triangle blah 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 is congruent to triangle blah blah blah. So we have two triangles, like triangle 1 and triangle 2 right here. You can name the first triangle whatever you want. Right? You can pick triangle ABC, you can call it triangle CAB, triangle BCA, whatever you want to call it. It doesn't matter what you call the first triangle. Let's call it triangle ABC just for simplicity. But it totally matters what you call the second triangle. The second triangle must be listed in corresponding order. Since angle A has one arc mark in it, it will correspond with angle J, which has one arc mark in it. B corresponds with K, and C corresponds with L. You must write your congruent statement in corresponding order. A goes with J, B with K, and C with L, and etc. Now let's list all corresponding parts. So angle A is congruent to angle J. Angle B is congruent to angle K. And angle C is congruent to angle L. Also the segments, segment AB is congruent to segment JK. Segment BC is congruent to segment KL. Again, this was the last two dudes, goes with the last two dudes. And finally, the first and the last letter, segment AC, is congruent to segment JL. You want to stay away from the picture and try not to look at it. Sure, these triangles are written side by side and very easy to tell what corresponds with what. But when things get a little crazy and they're not already marked for you, it's a little more difficult to figure out what corresponds with what. That's why we roll off of this congruent statement. So these bros are congruent to each other because we got all 6 pairs of parts. So let's call the first triangle whatever we want. How about calling it triangle ABC? And now we got to write the second triangle's name in corresponding order. A had 1 arc mark, it goes with D, which had 1 arc mark. B in the blue triangle, because there's a bunch of B's, like angles with B's in them. B in the blue triangle had 2 arc marks. It should go with point C in this triangle over here, which had 2 arc marks. And then comparing from blue triangle to green triangle, if you will. So B in the blue triangle goes with C in the green triangle, and then if you go with C in the blue triangle, it has 3 arc marks. It corresponds with B in the green triangle. So kind of tricky, you got to go a little slow there. And now we can list all these vertices in corresponding order. It's cool to call this angle A because it's the only angle with A for a vertex in this picture. It goes with angle D. But calling this angle B right here, we can't do that because there's more than one angle with B for the vertex in this picture. So we got to call this by 3 letters. We can call it angle ABC. Remember, B has to be in the middle, and A and C are the other 2 letters. It's congruent to angle A goes with D, right? B goes with B, and angle DBC, just like that. B's got to be in the middle because it's the vertex angle DBC. So cool. And then also with angle C, you cannot call it by 1 letter because there's more than one angle with C for vertex. So ACB, C has to be in the middle, is congruent with angle DCB. Those are the 3 angles. Segment-wise, we can just use the congruent statement. Segment AB is congruent to segment DC, and segment BC is congruent to segment CB, and lastly, segment AC is congruent to segment DB. Very nice. Now in number 3, it's kind of goofy because it doesn't look like we have all 6 pairs of angles and sides marked congruent because we got arc mark, double arc mark, triple, triple, right? Angle-wise, we're good to go. But when it comes to the sides, you know, here's a single, there's a double, but I don't have like that third side marked. Well, if we kind of focus in on these triangles, we have 2 different triangles here. I got a red triangle, and I have a green triangle. But you notice how right here I have red and green highlighted on the entire segment. This segment BC is what we call shared between both triangles. So since it's the same segment in both triangles, it's got to be congruent to itself, so we need to put a triple tick mark on it. It was shared between those 2, and the reason why we can do that, there is a justification. It's called the reflexive property of congruence, because segment BC is congruent to itself, right? Segment BC is congruent to segment BC. It's in both triangles. So that's called the reflexive property of congruence. It's something that we will be using a lot this chapter. Well, let's write our congruent statement now. We got this triangle in green right here. Let's call it triangle ABC. It's congruent to triangle. Now in the black triangle up top, A has 1 arc mark. It goes with D. B has 2 arc marks. It goes with C. And C in the green triangle has 3 arc marks. It's got to go with B in the black triangle up there. So just putting them in corresponding order. Then angle-wise, you can call angle A because it's the only angle with A for a vertex in the picture, being congruent to angle D. And then angle B in this green triangle, you have to call by 3 letters because there's more than one angle with point B for a vertex. So angle ABC is congruent to angle this guy right here with 2 arc marks, DCB. And then lastly, in the green triangle, I need the triple arc mark guy, which is angle ACB is congruent to angle, the triple arc mark up here is DBC, excuse me, DBC. Something we got to take our time with. Now, segment-wise, like we said, segment AB single goes with segment DC. They're congruent to each other. Segment DB up top is congruent to segment AC. And then segment BC is congruent to segment BC itself. So, rock and roll. In the picture at the right, triangle ABC is congruent to triangle DEF. They give me a congruent statement. This is what we focus all our attention on, right? The picture is great, but we want to find what corresponds with what by using our congruent statement. They say find the value of x for problem 4, find the value of y for problem 5. Well, let's try problem 4, find the value of x. I got to look in the picture and find some expressions with an x in it. Here's an expression with an x in it, and it's on segment EF. So if I look to my congruent statement, segment EF would be these two guys. Segment EF corresponds with segment BC, these two guys. Segment BC, segment EF. Why don't we put single tick marks on those bad boys, realizing that they go together. See, this isn't good for me to write an equation with these two expressions because this has both an x and a y in it. I need to know like one of those variables. So instead of finding x first, what if we found y first? We could do that because here's an entire expression with only a y in it. It's in angle D. So if I realize that since these are congruent figures, any pair of corresponding parts should be congruent, angle D corresponds with angle A according to our congruent statement. Angle A is 65 degrees. It goes with angle D, so I can do this. I can say 2y minus 5 equals 65. Now I can solve for y. Add 5 to both sides. Then get rid of the times 2 by dividing by 2, and y equals 35. Now that I know that y equals 35, I can use that to help me write my equation with these two. Since segment EF and segment BC are corresponding parts of these congruent figures, they should be the same. So 2x plus y, or I'm going to write it as 2x plus 35 by substituting in, is the same thing as 90.6. Why don't you pause that video and solve for x. So if you subtract 35 from both sides, you should have got 2x equals 55.6. Then divide by 2, and x equaled 27.8. So use the congruent statement to figure out what corresponds with what and solve for your variables. Let's do that again here. No more triangles. They say that this quadrilateral ABCD is congruent to PQRS. So find the value of x. Here's a dude with an x in it. It's in angle A. A corresponds with angle P, so I do know that these puppies are the same right here. I can write an equation with them. 2x plus 4 equals 100. Subtract 4 from both sides, and then divide by 2. 96 divided by 2 is 48. Let's see if you can use the congruent statement to write an equation that you could use to solve for y. So here was the guy with the y, and it's segment DC. It corresponds with segment RS. So 3y minus 3 equals 12. 3y equals 15. Y equals 5. Draw and label a figure to represent triangle ABC is congruent to triangle DEF. Then solve for x and y. So let's grab our geometer and let's just draw a triangle. It doesn't matter which one you pick, but why not shape 2? What do you say we draw shape 2? So we can draw in shape 2. It's a triangle that looks like so. See, we need 2 triangles. I need one for triangle ABC and one for triangle DEF. So they should be congruent to each other, which means that they're the same size, same shape. Why don't we draw another shape too, right next to it? Make them side by side, looking just like each other. So there's my two congruent triangles. One of these bad boys has to be triangle ABC. One of these bad boys has to be triangle DEF. So if ABC goes around the clock clockwise, put the DEF in corresponding order, right? A corresponds with D, so we do need to mark this stuff. Angle B corresponds with angle E, and angle C corresponds with angle F. Then we need to mark the side lengths. Segment AB corresponds with that guy. This guy corresponds with that guy, and etc. So there's how to draw two congruent triangles representing triangle ABC is congruent to triangle DEF. Now let's put this info in our picture. So distance from A to B is 7, distance from B to C is 9, distance from A to C is 11 plus x. Distance from D to F, be careful, is 3x minus 13, and the distance from D to E is 2y minus 5. So we got all our info in there. Now let's solve for x and solve for y. So here's a guy with an x. It's got a triple tick mark. It's on segment AC. It should go with the triple tick mark, which is this guy. Hey, they both have x's in them. That's nice. So 11 plus x should equal 3x minus 13. Now we can solve that for x. Why don't you pause the video, solve for x. And hopefully you solved for x and got x equals 12. Now it's time to solve for y. It is on a single tick mark segment over here. It corresponds with this 7, which is also on a single tick mark. So 2y minus 5 should be the same as 7. Add 5 to both sides and get that. And divide by 2 and y equals 6. So using the congruent statement, everything's in corresponding order. And what we're going to discuss in this chapter is how to prove that we have triangles congruent. So many chapters ago we studied congruent triangles, and that meant that they're the same size, same shape. And two triangles are congruent if all 6 pairs of things, like this 3 sets of angles, like angle A congruent to angle D, angle B congruent to angle E, and etc., and the set of sides, like segment AC congruent to segment FD, and etc. If you had 6 different pairs of corresponding parts that were also congruent, we knew that triangle ABC then would be congruent to triangle DEF. Well, what we're going to do is we're going to prove that we have congruent triangles this chapter, and to do this we don't need to actually have all 6 pairs of corresponding parts congruent. There's 5 total ways we're going to be able to prove triangles congruent. Today we're going to learn 4 of them, and let's just kind of go through those on this front side of this worksheet. So here's 4 of the 5 ways we'll learn how to prove that we have enough information that triangles congruent. So the first way is called side-side-side congruence theorem, and we'll abbreviate it like this: side-side-side SSS. We'll never say SSS. We'll call it side-side-side congruence theorem, but we'll just write it down like this. And here's what it means: if you've got 3 different sets of sides that correspond to each other, and they're congruent, like see segment AC is congruent to segment D, that's an F right there, DF, like they're congruent by the tick marks. Then you got these blue set of sides, and you've got these green set of sides. You have to have 3 different sets of sides that correspond to each other, and they're also congruent. That's enough information to prove that those 2 triangles are congruent, and how we write it down is side-side-side congruence theorem. That says that those 2 triangles would have to be the same size, same shape. So that's one way we'll know. Another way is called side-angle-side congruence theorem. Now notice when it's written like this, it's a side, then an angle, and then a side congruence theorem. This angle is between the 2 sides. Like if I go around, let's go from starting from this tick mark, if I go around counterclockwise, I've got a side, then I've got this arc mark right here, and then I got another side, a single tick mark, single arc mark, double tick mark. In the other triangle, don't I have that exact same information? Single tick mark, then that single arc mark, and then this. So like if this was 4 inches and this was, let's say, 40 degrees,
and this was 6 inches, then this would be 4 inches due to the tick marks. This would be 40 degrees, and this would be 6 inches. That's enough information right there to prove that those triangles would have to be congruent because of what's called side angle side. That angle is between the two sides. Notice if you do this, if you had two triangles right here, you went side, this angle, this arc mark, is not between those two sides. If you got to go around like consecutively, either clockwise or counterclockwise, if you went from here to here to here, that arc mark is not between the two sides, so that is not enough information. Here's also another one that says this is not side angle side, and people go, well, okay, what if you went from here, let me use a different color. What if you wanted to go from this double arc mark around this way, Mr. Fonesteel, and said I want side, angle, side? This doesn't work because of this fact. Look at how many things you skipped over. You can't skip two things in a row. Like if I went around the clock this way, isn't it true that I skipped over this angle right here? I skipped over that angle, and I skipped over this side. I just skipped two things in a row. I skipped an angle, and I skipped a side. You can't skip two things in a row. So you jumped too many steps, basically. You can't go side, skip, angle, side. It just doesn't work that way. So that's not side, angle, side. Why those two triangles are congruent if they are. So side, angle, side, you have to go around consecutively, and the angle, the arc mark, has to be between the two sides when you do it. So it's got to look just like that. Another way to prove triangles congruent is called angle side angle. And notice it's like the same idea, only backwards. That side has to be between two angles, just like this. If I went here and I went around consecutively, I went from an angle to a side to another angle, and it's right in a row. Angle, side, angle, angle, side, angle. So that is another way that just to prove that you have enough information to say those triangles would have to be congruent to each other. If angle, side, angle. Here's an example of angle, side, angle not working, because you see that the tick mark is not between the two arc marks. And what it really boils down to is if you wanted to go around like this, it's like, well, I'm going to put the tick mark between the two. You skipped too many things in a row. You skipped over, highlighter, you skipped over this segment, it had no markings on it, and you skipped over this angle, which had no markings in it. You can't skip over two things in a row that don't have marks on them. I guess that's a better way to say it. You can't skip over a segment and an angle in a row that don't have markings on them. You skip two things without markings. So that doesn't work for angle, side, angle, because the side is not between the two angles, because you skipped two things in a row. Okay? And then on number 4, the final way today that we'll learn how to prove triangles congruent is called angle, angle, side congruence theorem. Angle, angle, side. You notice the order you go, and you got to go from an angle to another side congruence theorem. So it's just like this. If I went around this way, this works. And people go, wait a minute, you skipped over something. It's okay to skip one thing in a row. Like, see, I had this arc mark, and then notice I totally, skipped this side. It didn't have a mark on it. This segment does not have a marking on it. So I skipped one thing, and then I got to this angle, and it does have markings in it. So it's not like I skipped two things in a row. I only skipped one thing in a row. I went an angle, skip, to an angle, to a side. Angle, angle, side. Angle, angle, side. So that's another way to prove triangles congruent. But angle, angle, side is the trickiest one of them all for this reason. Let me back it up here. If you're going to go single arc mark, double arc mark, then side, this guy has to go in the same order when you go around the clock. So I went around the clock clockwise. You have to go, if this one went single arc mark, double arc mark, side, this one has to go single arc mark, double arc mark, side. The arc marks, the two angles, they have to be in the same order. Single, double, side, single, double, side. Here's an example that doesn't work. Like, if you go around the clock this way, from here to here, notice you went double arc mark, single arc mark, side, and then same direction that you go around here, same orientation. You went, the arc marks got all switched around. It went single, double, side. So this is not angle, angle, side, because the angles were in the wrong order. right? If I put numbers in there, if this was 70 degrees and this was 60 degrees, and then this one, the double arc mark, is 70 degrees, this one's 60 degrees, you switched them around, right? It has to go 70-60 side, 70-60 side, and it didn't work that way. So not angle side situation. Some people look at it like this. It's like, well, what about side angle because I went the other way? It's like, that's the same concept, right? Angle side and side angle it's the same thing. We just don't call it that. It means you kind of went in the wrong direction. We want to go clockwise instead of counterclockwise. So angle side. I know that was pretty weird and a little bit difficult. It gets better. I want you to try the backside on your own. See how many of those you can prove congruent. And if you can't, then you just write no congruence. But go ahead and give the backside a try, and we will go over it next time in class. So see what you can do on the old backside, and see me for any questions. I'll help you out if I can. That's all. Have a good one.